afternoon, students. I hope you are well. I hope you have studied the previous lessons. So we will continue, okay? Lesson number 9 in chapter 6. So we will continue questions from the online website, okay? So let's start. Now, the boiling point of water, H2O, is higher than the boiling point of hydrogen sulfide, H2S, because water molecules are what? Okay, because water molecules are what? You should know. Now, the electronegativity of oxygen is higher than the electronegativity of sulfur. Okay, so this means what? The water molecules are more polar and form hydrogen bonds. Okay, so the answer is D. Okay, question 16. Now, even though the following molecules contain polar bonds, the only polar molecule, now obviously you can know CCl4, CO2, CH3, all of these carbons contains carbons, and this one only it's NH3. So a hint you can know from here. The answer is C. But how can you know correctly? Okay, all of these carbons, okay, full octet, okay, without any lone pair. But the nitrogen, it has a lone pair. So now, even though the following molecules contain polar bonds, but only polar molecule, the whole molecule is not polar. This one, because contains lone pair, so it's what? The answer C. It is a polar molecule. Okay, so question 16, the answer is C. So let's continue now. The boiling point, let's continue. Now, as atoms bond with each other, they what happens when atoms bond? Let's read. A, increase their potential energy, thus creating less stable arrangements of matter. Okay, that's wrong. Decrease their potential energy, thus creating less stable arrangements of matter. That's also wrong. Okay, so increase their potential energy, thus creating more stable arrangements of matter. That's also wrong. They don't increase their potential energy to create more stable. They decrease. You see why the bonding happened, so that they become more stable. So they decrease their potential energy, thus creating more stable arrangements of matter. Okay, so the answer is D. Now, here for this one, okay, we will discuss it later, okay, when we take the lesson about hybrid orbitals. Okay, but the answer for question 18, it is B, CO2, and we will take the hybrid orbitals, okay, sp3, and the types of hybrid orbitals. So now question 20, which is the correct Lewis structure for SiF4? Okay, silicon with fluorine. So is it this one? No, wrong. All the fluorine atoms, the 4 of them, are bonded with this Si. So this one is wrong. This one, okay, all of them are bonded, but how many lone pairs for each fluorine? It's wrong. Okay, each fluorine has a full octet, 8 electrons. So that's wrong. Now, this one, not all the fluorine atoms are bonded with the silicon. So it is wrong. So obviously this is the correct answer. All the fluorine atoms are bonded with the silicon, and look, the lone pairs, each fluorine has 8 electrons. Okay, C2, 4, 6, 8. Okay, so this is the correct answer, A. Now, question number 21. Which is the correct Lewis structure for C2H4? Okay, which one? So I will give you a second to think. Now, you have C2, so C2, but you have 4 hydrogens. Now, so this shows that each carbon, okay, is bonded, but you have a double bond. Okay, you have a double bond. These structures are called alkenes. So there is a double bond. So this structure is called ethene. So this is the correct structure. This is the correct Lewis structure for it. Okay. Now, here how it is wrong? The hydrogen, wrong. Too many lone pairs. That's wrong. Here also the carbons, too many lone pairs. That's wrong. and the hydrogen, they don't make 4 bonds. Here also, you see. So the correct answer is this one, C. Now let's continue. A shorthand representation of the composition of a substance using atomic symbols and numerical subscripts. Okay, so a shorthand. Okay, what is it? So I know when I use it, okay, using atomic symbols and numerical subscripts. So this is called what? It is called a chemical formula. Okay, it is called a chemical formula here. Now, question 15. A charged group of covalently bonded atoms. So the atoms are covalently bonded, but it is charged. So it is a polyatomic ion. Question 16. A covalent bond between two atoms produced by sharing 2 pairs of electrons is called, remember, sharing 2 pairs. So it is a double bond. It is a double bond. Question 17. The simplest collection of atoms from which the formula of an ionic compound can be established. Okay, the simplest collection of atoms. I explained this in the previous lesson. You should. I hope you have studied. I will give you a second to think. So the answer is formula unit. Formula unit is the simplest collection of atoms from which the formula of an ionic compound. Okay, it's the simplest. So let's continue. Now, the energy required to break a chemical bond and form neutral isolated atoms is called what? Okay, what is it? It is obvious. It is the bond energy. I need this energy to break it. So it is called bond energy. Now, question 19. A chemical bond that results from the attraction between metal atoms and the surrounding sea of electrons is called, okay, what is it? So it is called, we saw a video about it. It is called metallic bonding. It is called what? Metallic bonding. You can know from the sea of electrons. Now, the property, or you can write metallic bond actually, because he's asking what is the chemical bond. So you can write a metallic bond. Now, question 20. The property of being able to be drawn, pulled, or extruded through a small opening to produce a wire. So this is one of the properties of metals, okay? It is called ductility. So I can make wires from this metal. So it is called ductility, okay? So this is the end of our lesson. Thank you.